Hello everyone, I am Sui Prakash, Research Scholar, Department of Electrical Engineering, IIT BHU. Okay everyone, let's start the session. Take a question number first from flyway converter.
We can take up some questions of the gate driver question and remaining number, I guess number is done.
Your voice is not clear.
Sorry, clear on this.
Okay.
So yeah, also we can take up questions on first one. Okay.
Question number first, for designing a flyway converter, sourcing power from a 150 volt input voltage source and supplying to the 10 ohm load. Select the correct option from the following choices. Are the given below specification for ideal diode and transistor. Input voltage is 150 volt, output resistance is 10 ohm, duty cycle is 0.4, and number of turns from primary to secondary is 5. And this one is different. 5 is not taken, like 2 for this output. 5 printed by mistakenly. You know about flyback converter? Flyback converter work like a buck boost converter. And DT
This is a step down transformer, right?
Yes. Mainly flyback converter is used for the isolation purpose. And in driver circuit, MOSFET driver or IGBT driver, this power supply is isolated power supply used in driver circuit. That's why the flyback converter is used there. It's a simple structure and working piece are also simple for low power application. But here I have taken a 150 volt input voltage. We count like that. Why not? This one IC out because the voltage. A switch is present here. Like that, keep. Turn to 1, transfer can from primary to secondary. This voltage supply. It's a simple structure, but dot polarity are reverse in the transformer, like flyway converter dot polarity here to here. Dot polarity mentioned for the winding of coil winding directions. can take a magnetizing winding like that, one of them. LM of transformer. So magnetizing current. I take a primary winding current as I1. This is I2. Playback converter working like that. If your switch is on, then coil is store the energy like this one, because of this one positive polarity. So negative, dotted is positive, undotted negative, then diode will be reverse biased. In this condition, only output power supply by the capacitor only. In this condition, in this mode, magnetizing voltage directed to the Vs supply voltage, and the magnetizing current will start to increase. And is the continuous or discontinuous depending on the magnetizing inductance of transformer. Here we used a ferrite core transformer, like a pulse transformer for higher frequency. It is not a iron core transformer. Okay. In iron core transformer, the losses increase. It is a high frequency, like a 50 kilohertz, 100 kilohertz of any converter. Then when switch is on, Q is on. In that time, I am magnetizing of a transformer, store the energy, and Vm is directly proportional to Vs equation, and IC minus of O naught. Current will flow like that. For the reference, you can take a P naught by R. When switch is off, condition, the stored energy delivered to the output. Switch is off like that, and this IM store energy flow like to the input side, and this one is positive, this one negative, this one positive, this one negative. Level of current for diode is forward bias, and then is applied to the load like an inductor, charge and discharge time. In this condition, this one is a forward bias, and output voltage appears here, it's plus minus of V naught. Then here is the same as N V naught. Then Vm is a minus of V naught, minus of N into V naught, refer to the primary side. And inductor capacitor current like that, this one IL not is IM. If you use like IM, then IM is N into IM minus of I naught is the capacitor current. Because of this one current, this one IM current flow here through the winding, this primary winding, transfer to the secondary side like NIM minus I naught. You have a two equation, off time voltage equation and on time voltage equation and current equation. Apply the both second equation for inductor. It means on time Vm dt, on time plus Vm in off time period. The average inductor का voltage 0 per cycle, and Vm is the same as Vs into Dt. This one is a minus of n V naught to 1 minus dt is equal to 0. As you can find V naught here, dVs like Vs by n into d divided by 1 minus d. The output voltage equation for the flywheel converter. Something apply for the current equation.
Sir,
Yes.
sir, while writing the above equation, this IC equal to NIM. Sir, the N we have chosen is NP by NS.
In transformer, you know about the current and voltage transferring from primary to secondary. Na? This one is, yeah, if you transfer the voltage, then take the higher side. This one, if you take this one V1, this one V2, if you transfer V1 to V2, then take this one NS by NP
Okay.
into V1 is equal to V2. Same thing if you transfer current, then opposite of them. Because of this one is the higher voltage potential, lower voltage potential, if you calculate the power, primary side, secondary side, this means the higher potential, this one lower potential. It means secondary side is the current is more, in primary side current is less. That's why n multiply by the secondary side for transfer.
No, sir. This N is either NS by NP or NP by NS. This
NP by NS.
So
Sorry, N is NP by NS.
okay.
Because of I have taken n is equal to n 10 to 1. It means if you take NP is n and then output is 1. This one like that.
Sir, but you have drawn the diagram in the question. It is not given that N is to 1 is written by you.
No, this one is the given, I think, in questions. Clearly mentions.
No, this NP and NS are given, sir. But this N you are writing on the left.
Yeah.
On the top, N is to 1, you are writing N on the left. So if suppose N is on the right, if it is 1 is to N, then N is NS by NP.
Yes, yes.
So that creates that N what it is not given clearly here.
But I mentioned like n is the NP is divided by NS. It means the primary side is n and the secondary side is 1 you can take. If this one n someone n turned to 1, it means this one NP NS to 1, it means NP turned to NS like that.
Okay, in this problem we are taking like that.
Yeah.
Okay.
I think in your problems, I think this one is opposite, NS by NP is taken. Then don't confuse them, then confuse here. Sorry. Take when the clearly mentioned if any question. If they were not mentioned, then question will be incomplete. Because you can't define by yourself, no, where is the NP and NS and what is the
Sir, this is okay, sir. This NP by NS they have given clearly.
Yeah.
But this NP by NS is either it is equal to N or 1 by N. That is what is not clear, given clearly on the question at least.
Okay.
Is NP by NS
if you here mention like NP by NS, okay, then take NP is equal to NS. If you take like that, if you transfer there 1 time to NS divided by NP, it means 1 time to NS is 1 by N, this one. This become like that. If you transfer this one here, NP by NS 10 to 1, it means N to 1. If this one is mentioned like that, then you can take 1 time to N and 1 N 10 to 1. It is clarified. In all the questions it is mentioned, so don't worry. Type it. Same thing we apply for the current valence equation. IC into dt plus IC into 1 minus dt is equal to 0, like a charge balance equation. In the time, this one is a minus I naught into t dt plus this one n into Im minus of I naught into 1 minus t into t. T is a common and cancel. Minus of I naught into dt plus n into Im 1 minus t, t can take common, minus I naught plus of I naught into t. This one cancel out. Take like I naught is equal to n Im into 1 minus d. Now we can take find magnetizing current with respect to output current. I naught divided by n into 1 minus d. If you want to take this one, want to find this one ion current. Ion current flow only when the switch is on. If switch is on, then this one current will flow. If switch is off, then this current will be 0. Only Im is present. Same thing, same graph you find like Im in continuous condition. This one dt t, take a current capacitor current in this condition minus of I naught, and this is Im into n minus of I naught. Is approximately same as the Im when switch is on. The remaining time will be 0. Come to the questions is given like that. And what will the output voltage from this? I know about the voltage, output voltage, Vs by n into d divided by 1 minus d, n is clearly mentioned like 2. Vs is 150 volt, due to h equal to 0.4, then you can find V output. 0.4, this one 0.6. 50 volt.
Yes, sir, it is 50.
50 volt, no?
Yes, sir. Yes, 75 into 2 by.
Yeah. Okay, if you take a different turn ratio, then you can find this one. Leave it. Then output voltage like that. Vs by N into D 1 minus D expression. If you take a 5 for this one, which was clearly mentioned, then you find it as a 20 volt. Okay, this one is a 5, is like the V lot is equal to 150 divided by 5, 0.4, 0.6, 30 into 0.4, 5 into 4, 20 volt. Option B is correct. If you take a 2, then this one is a 50 volt. Referring to the previous questions, because for the output voltage ripple is 1% of output voltage, and the current ripple is maximum to minimum. So the transistor, when it is conducting, is 10% of input average voltage, that is current. Sorry. Select the correct option from the below choices of for LP inductance in from the primary side and value of capacitor to output capacitor. Inductance seen from the primary side is simply, if you in the leakage inductance is 0, ideal if you take leakage inductance is not present, then LP is the same as the look like the magnetizing current, magnetizing inductance LM. In equivalent circuit in transformer, if leakage winding is 0, then only magnetizing winding is present. Then if you take like magnetizing inductance, like this one LP is same as magnetizing inductance. If you take at this value, then output of current should be 10% of the average input current.
Sir?
Yes.
Sir, in that flyback converter,
Yes.
The primary side of the transformer we had this magnetizing winding, and then the other winding is there. So, yes, sir. Yeah, in that we have magnetizing winding, and then the other winding which carries the
this,
second.
Yeah, this one only for the transferring the power from primary to secondary. If you take a equivalent circuit of transformer, it is clearly mentions only for leakage inductance and magnetizing inductance. This one is only for the transferring the voltage from primary to secondary only, used like that. And this inductance directly used like E1 and E2. It is not counting inductance. Inductance counting only leakage and magnetizing. Because of this one, this one shows like a primary inductance. Primary inductance is same as E1 L di by dt, and same can written in transformer as N d phi by dt. That's why you leave it.
Yes,
that's why you leave the inductance of primary side and secondary side. We count only the leakage and magnetizing inductance.
So this is not the inductance; it is just a winding which has EM.
Yeah.
Okay. So those inductance are only represented as the leakage and magnetizing.
Yes.
Okay.
Equivalent circuit of transformer, this will only present. And then
The inductance on the
yes.
Sir, the inductance on the secondary windings will also be referred to the primary. So it will be added to the leakage itself on the primary.
Yes, but leakage I will take a leakage 0. Then then only magnetizing current will present. Magnetizing inductance will present.
Yes. Okay. Yeah, okay, sir. You can go ahead.
Now the Vm magnetizing voltage is same as the Vs in on condition. If you take a ripple in a Vm, then you can look L dim by dt is Vs, and dim is equal to Vs by L into dt. Integrated this one from I minimum to I maximum. This one is a constant one, then Im should be I max minus I minimum is delta Im equal to Vs. This one integration from 0 to dt to find the ripple current. Vs into dt by L, and it is Vs d by Fl. This is given as a transistor switch current. Then ripple is maximum to minimum and switch is on, or is this one a conducting type? It means this type. This is the same as the magnetizing current. You can take as the same as the magnetizing current. The switch is on, then transformer current same primary side same flow with the magnetizing current as switch current. Then switch is off, then magnetizing refer to the secondary. Then this ripple is the same as this one ripple. Given a delta IL, delta I1 is equal to 10% of I1. I1 it means same as delta IM. Delta IM is 10% of primary current. Primary current is of I1. This one is one input average current. You can calculate input average current is same as V output. I output is equal to Vs into Is. I calculated this one like Vs is 150 volt and V output is 50 volt, 500 equal to 2. R is given like 10 ohm, then I output is 5 ampere, then Is you can calculate. .66 ampere. Then delta IL is 10% of this one I1, 0.167 ampere. The ripple is delta maximum to minimum is delta IM Vs into D divided by FL. You can calculate as inductance. Vh is 150 volt into 2 to the raised 0.4 divided by frequency and delta IL is 0.167. Inductance is, you can calculate this one. So 161.44 divided by F. Expression and same you can calculate delta Vc is 1% of V naught is equal to 0.5. Delta Vc is same as I naught into D in algebraic boost converter. Because of this one IC is present, then you can find delta change as I naught into D dt time. You can calculate C value. I naught is 5 ampere into D is 0.4 divided by F frequency into delta Vc 0.5. L is 361.44 into F and the C is 4 by F. Then match the question, but this one first one, if frequency is 100 kilohertz, 120 kilohertz and 150 kilohertz, then find this one for 3 frequency. Frequency in kilohertz, L and C, and 1 kilohertz, 100 kilohertz, 120 kilohertz and 150 kilohertz. Same thing if you divide by this one by 100, I think 3.6 millihenry, and this one is 40 microfarad. Maybe 120, 361 divided by 0.44 divided by 120 and 3 millihenry, and this one is 4 divided by 120 . 3 microfarad and 150 kilohertz. 2.4 millihenry. Same you can calculate for the capacitor, 150 kilohertz, 26.6 microfarad. For the different frequency, different inductor and capacitor value. Next is given after designing the above converter. From question 2, which is the operating at 200 kilohertz of switching frequency, then what is the peak current through the transistor?
Sir,
Yeah.
and in the previous question,
Yes.
if you want to know the del IM when the switch is off,
Yes, sir.
yes, sir, actually del IM when the switch is off is the reflected from the secondary.
Yeah.
So it is N I naught.
This one.
Yes, sir. The current through the magnetizing inductance del IM when the switch is off. What will be the equation, sir? If
This one is like the NIM, na?
Yes, sir. It is NIM.
This one NIM. NIM is, if you take this one average of this one, same as the output, because of the average of a capacitor current is 0. Take average of this one. What is the average? I think NIM into 1 minus d time t divided by t is equal to I naught. Then I naught try to calculate is NIM into 1 minus d. I think same will calculate here. The switch is off, it means 1 minus dt time.
No, sir. I'm talking about this del IM. The del IM on the negative, del IM and the switch is off. This is IM. That is okay.
Del
This del IM we got.
this one is average only. By for the peak value, then this one is the current also present, na? IC. Instantaneous, for the instantaneous current, then IC and IM both are present. In that condition, you can take as this equation, minus of V naught. So minus of n V naught is applied in this. If you take this one, maximum or minimum, integrate from maximum to minimum, then you can find this one, delta IL. Like I maximum to I minimum di minus n of V naught divided by L integration of dt to 1 minus dt.
Yes, sir.
Then minus delta of IL minus of n V naught by L into dt minus of, sorry, this one is t minus dt minus of dt, like that. Minus minus are cancelled out, and V naught divided by L 1 minus 2 dt. This one will be negative. Negative means slope will be downside, go to downside. This one will be positive, it goes to the upside.
Sir, this NV not how we got, can you please explain, sir?
I think
On the negative side, on the when IM is decreasing, you have written the slope as minus NV naught by L.
yes.
How we got this minus NV naught? Please explain.
I take like this one voltage applied to the magnetizing winding. VM is in this condition minus of V naught by L, n minus of n V naught by L. That's why I've taken this one. See, look here.
Okay.
This one I reference as my plus minus VM.
Okay, sir.
This one dot polarity.
Ah,
Okay. This one V naught connected here.
yes.
Plus connected to n dot. It means this one is positive. Minus connected to dotted. This one negative.
Yes, sir.
Negative of this one transfer from secondary to primary. This one n V naught.
Oh, it is stepping up.
That's why I take a VM is equal to minus of n V naught.
Okay, sir.
Slope is minus of V naught divided by L.
Okay. Understood, sir. Thank you.
So question number 3 is given, like what is the peak current in through the transistor? Peak current, it means primary current of peak. So I1 current plus delta IL by 2, average of this one I1 plus the ripple of this one. I1, this average current we calculated 1.67, and delta IL 150 divided into 2.4. Frequency is given 200, it means 200 kilohertz, 10 to the power 3 to 2 millihenry, 2 into 10 to the power minus 3 Vs D divided by FL is delta IL. Then you will calculate this one at 1.745 ampere. This one maximum, the peak. Peak means average of current plus delta IL by 2.
Okay, this is the current through inductor, output inductor they are asking.
No, this one is primary IM. This one primary voltage na Vs. Here is not an output inductor na.
Yeah, no
Five-way
output.
converter.
Yes.
That's right. Next question is for the fixed ferrite core inductor, what will be the ratio of stored energy E1 to A2 if the peak current through the inductor are I1 and I2 is like 10 ampere and 15 ampere respectively. If a voltage source applied to the inductor, same to this one V, no current of I. You know about V is L di by dt. Then V dt is equal to L into di. What is energy? No energy is equal to V into I into T. Voltage current it multiplied by time. We want to calculate total energy. If this one current is not constant, voltage also not constant, that's why we take as a integration of this one, a small changes of energy and a small changes of time, then integrate this one. V into dt you can replace by L di, I into L of di. This one V and T replaced by this one, and dE is equal to I, so L into I into dt. Sorry, this one di. Integrate in both sides, find final energy of L is a constant. Then I with respect to integration of I with respect to I is I square divided by 2. It means of energy stored in the inductor is a half L into I square. I think you know all about this. So equation half of Li square is a stored energy in inductor. You can same thing apply for the capacitor. You can find stored energy in capacitor is a half C V square. Then you can relate this one, E directly proportional to I of square, then E1 by ET is I1 divided by I2 whole square. I1 is 10 ampere, I2 is 15 ampere. I calculate this one 44 E1 by E2. Next question is given the detail of the coil 1 and coil 2 are listed below as coil 1 ferrite core. I think both are for ferrite core. Ferrite core means applicable for a high frequency. It's not a laminated core. It one is the solid core of ferrite material. A normal transformer for the AC system you used is the laminated transformer, laminated iron core transformer. But here the ferrite core, it means a solid core made by the ferrite material to use for the high frequency transformer like a pulse transformer. Then this one is the for the converter, any SMPS converter, use of a ferrite core. Then ferrite core is mu R1, the permeability of material is 1500, and this one IL this one L net I, this one L length of mean length of the core. For the coil 1, this one core is like this. This one is the whole mean length of the core, and this one is the air gap of the core. Basically, air core is provided in any ferrite core for the carrying a high current without a saturation. Because of the, if you apply air gap between the core, then it has a high permeability and capable of a high flux. Then you can flow the high current up and normal current. Then the normal current flow this core. Then mean core length is given like this one, here to here total length is 98 mm, and the air gap is 2 mm. Provide this core. Cross sectional area is a 40 mm square of this one, and number of turns in primary is 100. Sorry, in core 1 is 100, and the current 5 ampere flowing through the winding. This one, and same thing apply for the core second, and this there is not provided any air gap. Same thing, 1500 mm, and core mean length in total 100 mm, because of air gap is not provided in this core. Cross sectional area is 40 mm square, same as the first column, and number of turns is 50, and current is 5 ampere flowing through the coil 2. This dimensions consider standard value of probability of free space like a mu naught. We know about the mu naught value is 4 pi into 10 to power minus 7 Henry per meter. Then flux in coil 1 is phi 1 and coil 2 is phi 2. Then what will the ratio of flux coil phi 1 and phi 2? Asking about in the questions. Phi 1 and phi 2. You know the magnetic core, magnetic material, phi is same as m by reluctance, same as a current by the V by R. The current related to the flux, V is related to the MMF, and R related to the reluctance. MF is N into I. We have reluctance. Reluctance represented by the L by mu A, where L is the length of the core, A is the cross-sectional area of a coil, mu is the mu naught permeability. Absolute permeability and relative permeability. If material is present, then mu R is present. If material is not present in air core, mu R is same as the mu naught. Then you can say like phi is equal to n I mu naught mu R into A divided by L is the flux. But here air gap provide, then this is the different. When air gap is not provided, then this phi calculated by this one, like in second coil, can calculate this one for second coil. But first coil is the two condition, is the air gap and without air gap. For the air gap, you can return like this one in a series of air gap reluctance. Like if you provide an MMF is Ni, you take this one core reluctance, this one not a resistance, right? Due to this one reluctance of mean reluctance of the core and this one for the air gap. You can relate this one in the series of core. Then you can find total flux. Total flux is total MMF divided by total reluctance. Total MMF is Ni divided by reluctance is Rm plus air gap Ni. Rm we know about L by mu 1 mu naught into mu r into A cross sectional of area plus in air gap. Take a Lm for the mean cross sectional area of core and this one for the air gap length Lg divided by the mu naught only because of mu are not present because of the air. This one is same as cross sectional area, but for the both condition is same. Then you can take a denominator as LCM for denominator. This one is LCM. Then Lm present only plus this one is mu r into Lg divided by mu naught into mu r into cross sectional area of A. Then finally flux you can find from Ni into mu naught mu r cross sectional of area A Lm plus mu r into Lg. This is the final flux, total flux of the core. First 5m for the coil 1, N1 I1 mu naught is the same. This one mu r1 into cross sectional area of A1 divided by Lm1 length. So mu r1 into Lg1 air gap length. N1 is given 100, I1 is 5, mu naught is 4 pi into 10 to the power minus 7, mu r1 is 1500. So written here I1. So check once. N1 is 100, I1 is 5, into 5, mu naught is given 4 pi to 10 to the power minus of 7, mu r1 1500. Cross sectional area is given 40 mm square. You calculate in meter only because of all of quantity in meter. Then calculate in meter is 40 into 10 to the power of minus 6 meter square. Divide Lm1, length of this one is 95 mm. Convert into meter, 95 into 10 to the power minus of 3 meter. In 1 meter 1000 mm. Plus mu r into Lg, mu r is 1500, mu r1 into air gap length is 5 mm, in means calculate in the meter. And you can calculate 5 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. will find 1.992 Weber. Phi 2, the N2, I2, mu naught, mu R2, cross sectional area I2 divided by LM2. Here air gap is not given. Air gap length is not air gap not present. That means air gap length is 0. Then only LM mean length present only. Then N2 50 and I2 5 ampere. And remaining is the same. Mu R2 same as A2 is 40 mm square. Cross sectional area 100 mm, 10 to the power minus 3. You can calculate this one. Into 10 to the power minus 4 Weber. Now phi 1 by phi 2. So this one is the micro Weber, means minus of 6 Weber, and this one is 188 micro Weber. Five and 5.27 10 to the power minus 3 phi 1 by phi 2. So 0.00527.
Sir?
Yeah.
Sir, in this case, this phi 1 by phi 2 is this value, which means compared to the second case, which is without air gap, in the first case with air gap, the flux is only this 5.27 into 10 to the power minus 3 times of the second case.
Yeah.
Because
In
the
second
current,
condition, when air gap is not present, that means that it will take a more flux. And
okay,
yeah, when air gap is
because
present,
reluctance is less.
yeah, phi is directly proportional to 1 by reluctance. Phi I by reluctance. If you provide a air gap, this means reluctance will be increased. Then if you more flex process through a core, then core will be go certain quicker saturated. That's why you provide a air gap between the core to take a higher current.
Big higher current.
Yeah. For high current, you can provide the air gap between the core. Then that core is sustain the higher current rate. Considering the above mentioned criteria, in question 4, the coil first and coil second, what is the ratio of instantaneous energy stored? Energy you know about half of L into I square. You know, and V voltage in coil and d phi by dt can same written as L di by dt. If you present in inductance, then L di by dt. If you present in a round number of turns, then N d phi by dt. If you take both side integration, then you find N phi is equal to N Li. You can calculate here inductance N phi by I. That energy is equal to half of L I square. L you can present like N phi by I into of I square. I cancel out, half of N phi into I. Yeah, you can written as MMF in terms of MMF, half of Ni into phi. So MMF for the both energy E1 divided by E2 is equal to N1 I1 phi 1 divided by N2 I2 into phi 2. Phi 1 by phi 2 already calculated. The N1 and N1 is 100, I1 is 5, divided by N2 is 50 into 5. This one is 5.27 into 10 to the power minus 3. I think this one is twice of this one. Same thing is flux is reduced, then it means energy also reduced. Energy that is equal to the fiber. Okay, next question: design a boost converter following below given specification. V in is 50 volt plus minus 10%. Output power is 200 watt. Our voltage is 200 volt. Switching frequency is 50 kilohertz. Inductor current equals 10% of the load current. Then calculate the value of minimum inductance required to satisfy the above specification. For the boost converter output given, then you can calculate the output current. 200 divided by 200, 1 ampere. V in plus minus 10%, it means 50. Minus 10%, it means 92 plus 10% 1.1, 45 to 55 volt. Ripple is current is given 10% of the load current, 10% of I1 is 1 ampere, 0.1 ampere ripple current. Boost converter, you know about the boost converter, inductor active proportional to the input voltage in switch is on. This one. When switch is on, then this was VL is same as the VS. Then VL is DIL by dt. You can find a delta IL here. I have a maximum to the VS to appreciate 0 to dt. Then same as VS into dt by L, it means 7. And V naught is equal to dVS divided by 1 minus Vs divided by 1 minus d. Vs also replace here. D into 1 minus d to V naught divided by FL. Given the minimum value of requirement of inductance, and find the inductance L. F into delta IL, delta IL is 0.1. First to calculate D minimum and D maximum. D minimum is V output is equal to Vs divided by 1 minus D. Calculate D here. V output minus Vs divided by Vs outputs. Then D minimum is Vs, we have V output minus Vs maximum divided by V output. .200 volt minus of Vs is Vs maximum 55 divided by 200, 0.725. D maximum is V output minus V minimum divided by V naught. 200 minus 45 divided by 200. To take a delta minimum occurs at a minimum. Vs is maximum. In that case, to take a delta D minimum, then you can find inductance value like 0.725. You can calculate this one, dI by dt. From dI by dt you can calculate the value, but you can, if you apply dI by dt here, directly find d equal to 0.5. But because of the restriction of the output voltage, you can't provide duty ratio below that 0.27 with the D minimum, 0.275. If you reduce this one from 0.275, which means 72.5% of duty ratio, then output voltage will be not constant. That's why you can take a minimum as possible. The minimum is 0.275 duty ratio. Then take this one only. Frequency is given 50 kilohertz. Zero point 1. Then you find the minimum value. Millihenry, like for the 10% of ripple.
Sir,
Yes.
sir, can you explain this problem again, sir? How? Sir, please explain this problem again.
This one you understand L delta IL.
Yes, sir. This is of the boost converter.
Yeah, for the boost converter, calculate from here. Then you can take L minimum.
Oh, yes, sir.
Then
We want to calculate L minimum.
Then L is equal to D into 1 minus D V naught divided by F into delta IL.
Yes, sir.
Here this one is very constant because of a given 0.1, 10% of output current. B output output is constant, frequency also constant.
Okay.
If you take
So
L minimum, you can difference this one with respect to D. Then you find 1 minus 2D is equal to 0. Then D is equal to 0.5.
Okay. So this is the value of D at which it becomes minimum.
That due to you can't take a duty 0.5 because of this one output voltage is not provided as a 50 volt. Sorry, 200 volt is what you want. That's why to take as a minimum duty ratio. The minimum duty ratio is this one. That's why take this one minimum duty ratio and find the minimum inductance.
Okay. Sir, actually here given is the input voltage is having ripple.
Yeah, that's why I reduce. I rearrange this one now. Then our input voltage is eliminated from the here. That's why I take as a voltage, output voltage only in this equation. If you take a voltage, input voltage, then you have a two variable, input voltage and duty ratio.
Yes, sir.
But here is only one variable, is a duty ratio.
Oh. So it depends on this element depends only on D here.
Yeah.
So we are taking D min. Sir, actually here there is a here there is D into 1 minus D.
Yeah.
So if you take D min, the second term will become maximum.
Yes.
Sir, somebody should switch off the mic.
But our ripple is 10%. If you take as a 10%, not more than 10%, in that condition, you should calculate the delta IL at which the voltage supply voltage is the maximum. When supply voltage is maximum, then directly reflected to the delta IL. Delta IL directly reflected to the VS. If you take the maximum, you should, in that condition, delta IL should be maximum. But this will not exceed the 10%. That's why take as duty ratio at where is the VS is the maximum. You can take this one also.
Sir, sir, can you hear me, sir?
Yeah,
Sir?
yeah. Yes, sir.
Sir, the other person, the Jagdish, I think
Yeah,
he's disturbing.
Jagdish. Yeah. Yeah, okay. Thank you, Jagdish. I understand from this delta
Sir,
IL,
actually,
delta IL directly reflected from the VS supply voltage. Then if you take the limit of delta IL, then should be calculated as the maximum distortion, distorted factor. This maximum distorted when the VS is the maximum. In this
okay. Oh,
condition,
del L by dt should be maximum.
yeah, maximum
Okay,
is 10%. I'll give like a maximum 10%. You can't exceed this one.
okay,
Then what is the value of this? If you reduce the value of L minimum from L minimum, then delta L will be increased of 10%.
mm-hmm.
That's why you can take another way this one. VS is maximum.
Okay, okay, sir.
Next question is given: a forward converter delivering output voltage of 50 volt with the input from the battery 12 volt. The operating frequency of the converter is 50 kilohertz with output load current of 10 ampere and operating at a 0.45 duty ratio. For doubling the output voltage of 12 volt battery is replaced by the 24 volt. Is double the input voltage. The minimum safe switching frequency with which forward converter needs to be operated. It means you directly apply a VS twice of VS. To find the output voltage double. Because a forward converter you can increase the duty cycle. That's why you take as a frequency term. And we know about the transformer core saturation. Directly depends on the flux or flux density B maximum. It still directly depends on the supply voltage and supply frequency. It should not be exceed. If this one is exceed this one, then transformer goes to the in saturation mode. Directly depending on the voltage and frequency. If you increase the frequency, that is okay. But if you increase the voltage, this one, then this one is violated. That's why you should maintain this one Vs by F of a transformer, of any transformer. So if you supply voltage increase from 12 volt to 24 volt, then it means Vs1 F1 is equal to Vs2 F2. So Vs1 is 12 volt, F1 is 50 kilohertz, Vs2 is 24 volt, and F2 you can calculate F2 I think twice time of F1 100 kilohertz. You should increase the frequency for the same operation. Yes.
Okay, sir. Sir, basically here we are doing that whole second balancing, right?
Volt second and core flux density also maintained. Both are same. This one the average of fluxes should be same. The same question, the modified inductance required to maintain the same load current ripple. If the inductor is 12 volt, sorry, this one 24 volt system. In starting is 24 volt. If you increase this one is 20. Sorry, starting at 12 volt. When you increase this one is 24 volt. Then he asks about the modification of inductance required. If you frequency increase also, question number same question is given. That means referring to question number 8, then you have if you have increased the output voltage, then you increase the frequency twice time. Then ripple, current ripple, you know about the current ripple delta IL is equal to VL input voltage into D by FL. If frequency increases, Vs in this one is a constant, delta IL constant. It means increase the frequency. That means sorry, you can retain this one as a inductance in terms of frequency. Inductive proportional to Vs into F. This one increases 12 volt to 24 volt, and frequency increases to 50 kilohertz to 100 kilohertz. From the question number 8, it means if both are increased, then inductance should be same. You can take as the same inductance because of both are increases. Input voltage and frequency also increases. Then for the same ripple current, inductance will be same. The frequency increases and voltage is same, then inductance will be reduced because of inductance directly proportional to the Vs divided by F. Next question is for the forward converter. The forward converter is delivering a 25 watt output to a resistive load of RL. The specification are n is equal to 2. Here is mentioned clearly n in secondary side. N is equal to 2. V in is 100 volt. This one is 100 volt. This one is you can retain like this. This one. As Vs of V. It will be same. System frequency 100 kilohertz. Resistance load resistance is 100 ohm. LA design for the peak to peak ripple is 10% of the load current. This one delta IL is given 10% of Y0. And capacitor is designed for the peak to peak of 5% of output voltage. Delta Vc is 5% of V0. Magnetizing inductance is given of transformer 0.5 millihenry. And voltage drop also given 2.7. The value, the peak current flowing through the primary of the forward converter. This one current is asked. IP peak. So given IP here. You can rearrange the forward converter equivalent circuit. In this is the same. You can connect here also. Circuit same as IP. So magnetizing inductance is given that this is magnetizing current. I separate the magnetizing inductance from the current transformer. This one is the same as switch is on, then this current flow like that. Buck converter, switch is off, then this one there. and all of energy distorted from the resistance R M through the diode DM. Okay, as a peak current of IP. IP you can take like a IP peak is equal to IM peak plus this one current. This one current same as ID1 reflected to the primary side.
Sir, that is NIL, right? The current flowing through
Yeah,
the
N.
current,
Yes,
reflected
yes,
current.
yes, yes. NIL. NIL peak. N into IL peak. And IL peak. IL peak is same as I naught current plus half delta IL by 2. In buck converter, this one is ripple current IL dt t times average of this one is I naught, looks here only, this one IC, this one I naught, this one IL. Average of capacitor current is 0, it means average of inductor current same as the average of output current, like this one. Then what will be the peak value? This one IL peak, here to here is a delta IL, then you can written as IL peak is I naught, this one middle of this one I naught plus delta IL divided by 2, half of delta IL, this one, this current IL plus half of delta IL, this one current, this is the IL peak. Now first calculate the output current. P output is given as 25 watt, V output is 50 volt is given, then I output, resistance of RL is given, RL is 100 given, sorry, output voltage is not given, then calculate this one, 25 volt, watt is output power is given, and P output is know about V output is square divided by R. So we take a V output is a constant, then V output is square divided by R, resistance V out, then V output square is equal to P output is 25 into resistance is 100, 50 volt, I naught is equal to V naught by R, or I square R you can calculate from power also, 50 divided by 100, 5 ampere.
Sir,
Yes,
in the previous page, sir, you have written, sir, here, the primary current is the sum of IM plus the reflected current, right? IP is the sum of IM plus reflected current in the
yeah,
diagram.
I1, this one I1 I taken.
Okay, sir, this I1 is only N times IL, right?
Yeah, same as this one current.
Yeah, this I1. So IP is IM plus N times IL.
Yes, yes, yes.
Sir, but here it has to be plus, na, then IM peak plus, here the equation you have written,
Then I am plus this one. Yeah, yeah. So plus
okay,
of this one current. This one is the same as
okay,
N into IL peak. And IL peak
okay,
is I naught plus delta IL by 2. This one.
ah, okay,
Sorry for the equal to.
okay.
I not calculate here. V output, in the forward converter,
N into D into Vi.
N into Vs into D, Vs a V in. Take this one. If N is N tends to 1 is a transfer ratio, then Vn by N. It will. Then here you can apply 50 volt. N is given transfer ratio, N is equal to 2. V in is 100 volt. Then what will be D? D is equal to 0.25. Delta IL is equal to 10% of I naught. I naught is equal to 0.5 ampere. Then delta IL is equal to 0.05 ampere. Then IL peak. What is IL peak? I naught plus delta IL divided by 2. I naught is 0.5 ampere plus delta L by 2, 0.025. It will be 0.5 ampere. The same thing apply for the magnetizing current. IM Vm into dt divided by Lm. Because of the here magnetizing current, it will be like so like that in discontinuous condition. Some of time is required only. IM in a forward converter is not purely in continuous conduction mode. It will be in a normal case is in discontinuous conduction. Then you can take as a delta IL here is the same as the IL peak, IM peak current. Because the inductor present here, then it will not totally supply the output voltage, output current. It will be present IM in some of duration of time, on off time.
Sir, what you are saying, sir? This there is a discontinuous conduction of IM here.
Yeah.
So you are just saying something I couldn't.
I think like that if in a forward converter IM is not in the continuous conduction because of switching present here. So yeah, if you take like this one, then it will not be sudden zero. Switching is here on off. If this one is not present in this, if here present, that will be energy all of is distorted in the resistance.
Okay.
But in normal cases of magnetizing inductance of forward converter, it will be in discontinuous conduction mode only. It should be in this condition. It will be 0 and start from 0. When switch is on, because of switch is on in 0 condition.
Yes, sir. At the maximum, it can go up to T.
Yeah, this one dt time. When switch is on, then it will be stored energy in magnetizing condition. Then same as the delta IM, you can calculate it. IM divide IM into divide dt. And this condition, Vm is directly applied as a Vn here. When switch is on, Vm same as the Vs from here. That's why it will be written as Vm into dt time divided by Lm. Vm is given as 100 volt. duty cycle is 0.25. T should be, T can go for down denominator is FLM. Frequency is given 100 kilohertz, and magnetizing inductance is given 0.5 millihenry. You can calculate 0.5 ampere. This one will be the maximum of IM. Then IP current, peak current is equal to N into IL peak plus IM peak. This will be N into IL peak, 0.52 QL, IL peak, then 2 into 0.525 plus magnetizing current peak 0.5 ampere. It will be 1.55 ampere. So referring to the previous question, same as minimum power rating of the core flux resetting resistor in watt. Then actually resistor and capacitor is the resistance value of resistance is something, but is it also wattage value? What will be the lot? What it will do when you purchase a resistor? You should know about the resistance value. If you take if you ask someone for the resistance value like a 10 ohm or 100 ohm, then they will ask you then what is the wattage value of resistance. If you purchase anywhere, you can purchase the resistance. If you will go to purchase, then they ask you for the wattage value of a resistance, but in the capacitor case, the value of capacitance and is coming in the voltage range. What is the voltage range of a capacitor? In inductance, same thing. Inductance it will inductance value is okay, but it will coming in the range of inductance current, inductor current I. What is the value of a current? Then inductor will be go to saturation mode. It will come in the RMS value and peak value both. Then resistance is defined from the resistance value and wattage. Capacitor defined from the value and voltage range. What is the voltage of capacitor? You can apply. And inductor is the value of inductance and current flowing through the inductor. That's why it will ask about the resetting resistance, or I mean wattage value. What is the watts value of the resistor you use in the resetting winding? This one. It should be the energy stored in this magnetizing inductance, the same as, at least the same as this one, at a minimum value, minimum power rating. It means energy of IM is same as the energy of resistance. You can say the power P is equal to P into T is equal to energy. If you calculate power is energy divided by a time period. Energy is the, and in magnetizing inductance you can calculate as the energy. Same as half of L I square, L of IM square. What energy is stored in the magnetizing winding? Magnetizing inductance is given 0.5 millihenry, and IM current will be current is the IM peak current is 0.5 ampere. Now IM square, this one. So now energy. If you calculate power is equal to energy divided by time period. It means E into frequency. Frequency is given as 100 kilohertz. Then it will be as half of 0.5 into 10 to the power minus 3 and 0.5 half Li square into frequency of 100 kilohertz. You can find 6.25 of watt. We require this what is value of resistance. Resistance power. Resistance value depending on the spike of the voltage on the switches. Here switches represent because of the resetting winding. Here core is resetting from the resetting winding, diode and resistor. Then when switch is on off, somehow a spike occurs on the switches voltages VDS, and this voltage is reduced from the resistance given here. Then value of resistance depending on the spikes of the VDS voltage, source to drain voltage of the MOSFET, and the power rating depending on the energy stored in the magnetizing winding.
Sir?
Yes?
Sir, the resistance value is depends on the difference between the spike in voltage across the switch and the input voltage.
Yeah, yeah.
Okay, that is what you are saying, sir.
Yeah,
Is that what you are saying there, sir?
yeah, spike on the voltages VDS, and it should be energy should be greater than this one half R I square of R, also R into dt, 1 minus dt time na. It will be also greater than this one, but it will also depend on the spikes. If you take this one value of resistance, a spike is not reduces, then increase the resistance value. And voltage value should be greater than this one.
The resistance value we are choosing should be the difference of spike voltage and the input voltage.
Yeah. This one is the RMS current. Okay, everyone, I am stopping here.
Sir?
Yeah.
I have one more doubt in that eighth question. Eighth question, you have written that maximum flux density is as proportional to V by F.
Yeah, this one.
Yes, sir, this equation. Sir, how, where you arrived at this equation? This direct proportionality. Sir, can you hear me?
Yeah, because of the flux density, na, anywhere you apply the voltage, it will know about the transformer core in normal cases.
Yes, sir. Flux density we usually write as phi by A.
Yeah,
It is maximum flux.
this one is the IL,
Yes, sir.
DT, NT. So what the voltage is defined as L di by dt.
Yes, sir.
Can you written as this one as a total current and total time period, like IL into I average divided by the total time period TS. You can also define as the changes. This one is the current and this one is the changes in the reductor current.
Okay.
This one the changes from here to here. Then can we
Only
find
the average change.
Yeah, this one if
Uh,
you,
yes, sir.
then this one current is depending on directly to the flux of the core, flux of the inductor. Current is directly proportional to the flux, and flux directly proportional to Vmax.
Mm.
So can you say that V directly proportional to the Vmax into F from here? The Vmax should be maintained as V by F. This current value, what will the current is flow through the inductor, is dependent on the flux only.
Mm.
Our flux is depending on the flux density. Flux density into phi is equal to V into A, flux density into U. That's why I written as V as V by F is on. And in transformer winding in the normal transformer, this has also come in the picture, flux density. Like our core is a fixed flux density. It can't increase the flux density beyond the behind the rating. Core will be saturated. If you increase the flux density, it means we will increase the current directly. If your flux density increase, it means course flux density flux is equal to B into A. If you increase this one, because of this one cross sectional area of the core, it will be constant.
Mm.
Only flux density you can increase. If flux density increase, it means the flux increase. Flux directly proportional to current. If you current increase, this one is also increase. That's why this flux density will be maintained. It means the flux density into the flux per cross section area. This will be maintained for all time.
Mm.
You can't increase this one. If you increase this one, core goes to the saturation mode.
Okay. So this is the F is the voltage across the winding, and sorry, V is the voltage across the winding, and F is the frequency of the voltage.
Yes.
So those two should be maintained constant. Ratio should be maintained constant to keep B constant.
No. Yes, sir.
So, sir.
Yeah. Okay, everyone, I am stopping here.